Dear students, in this video lecture, we are going to learn about a new topic called robot technology. So, in this, you're going to learn about the basics of robot technology. So, what is robot and how it will perform the work, and all those we are going to learn here. So, you have seen robot in movies, right, where the robot can speak and it can do different tasks and it can communicate, it can listen. Okay, so and it look like human being. But so whatever the robot today we are going to learn here, that robot is called industrial robot. It is used in industries to do different tasks. So that we are going to learn in the further slides what is industrial robot. Before going to learn about industrial robot, first we'll understand what is robotics. Here we have a definition for robotics. Robotics is a multidisciplinary engineering field. It is not only a mechanical engineering field, it is a multidisciplinary engineering field. It is consists of mechanical engineering, computer science, electronics, mechatronics. Okay, so like this, it is a multidisciplinary engineering field dedicated to development of autonomous devices, including manipulators and mobile vehicles. This is called the robotics. So here we have a definition for industrial robot. Okay, so what we are learning here, it is called industrial robot because it is used in industries to do different tasks. Okay, so here we have the definition of industrial robot. Industrial robot is a general purpose programmable machine possessing certain anthropomorphic characteristics. Industrial robot is a general purpose and programmable. Okay, here we can program the robot, we can give some program of instructions to the robot so that robot will follow the instructions and it will do the work according to the given programmable instructions, and it is possessing certain anthropomorphic characteristics. What is anthropomorphic characteristics here is it possesses the characteristics like human being, so that is called anthropomorphic characteristics. The most typical anthropomorphic or human-like characteristics of a robot is its arm. Okay, so like our arm, so industrial robot can have an arm. That arm can have the characteristic like human arm and sensory inputs. Okay, so these are all the main characteristics or typical anthropomorphic characteristics of a industrial robot used in industries. I think you understood what is industrial robot. Industrial robot is a general purpose programmable machine possessing certain anthropomorphic characteristics. That is called the industrial robot. So what are all the features of industrial robot? So here industrial robot is having a mechanical arm or manipulator. It's having a mechanical arm or a manipulator, and robot can perform many tasks such as loading and unloading machine tools, spot welding of automobile bodies, and spray painting. So it can do the task in the industries that workpiece it can load into the machine to do the machining processes, and after completion of machining processes it can unload the workpieces. That is also one of the tasks, and it can do the spot welding of the automobile bodies. Automobile body, it can do the welding operation of the automobile body, so using a spot welding method, and it can do the spray painting. Okay, after manufacturing the car, the body we have to paint it. Okay, for that we use spray painting technique. By using that spray painting technique, robot can do the spray painting operation, and robots are used as substitutes for human workers. Okay, in many hazardous working conditions we can use robots as a substitute and in place of human being we can use the robots to do the work. That is the another main feature of the industrial robot. Okay, so these are all the main features of industrial robots used in industries to do different tasks. So next we have robot anatomy. Robot anatomy, how the robot looks like, how the robot construction is. So that is called robot anatomy. So here generally the robot is it consists of joints and links. A joint of an industrial robot is similar to a joint in the human body. For example, if you take your hand, the hand can have joints. Okay, so there is a joint in the wrist and palm, right? Okay, so there is a joint. So like this human hand can have many joints. Okay, in the fingers also we have joints. So here the industrial robot can have joints and links, joints and links. Okay, in the industrial robot like a human body, it provides relative motion between two parts of the body. So if you have two parts, those parts can have relative motion due to the joints in the human body. Like this in the robot also we can have joints and links. Okay, those joints and links can have relative motion. Okay, so that is the main anatomy of the industrial robot by using joints and links. In this diagram, we can observe the anatomy of the industrial robot is shown. So here, the first part of the industrial robot generally is a base, and we can have joints and links. We can observe here. This is called link 1 and this is called link 0. These two links are connected by using a joint that is called joint number 1. Again, another link that is 2 and link 1 are jointed by using another joint that is called okay link 2. So like this, these two links are joined by using a joint. Like this, it is having two joints and three links. This is the end of the arm. So like this, industrial robot will be consist of joints and links. By using those joints and links, it can have different motions and can do the work in many ways. So now we are going to understand what are all the different types of joints used in industrial robots. There are five different types of joints used in industrial robot. The first joint is called linear joint and shortly it is called as L joint, and orthogonal joint and shortly it is called as O joint, rotational joint shortly it is called as R joint, twisting joint and it is called shortly as T joint, revolving joint shortly it is called as V joint. So like this there are five different types of joints used in industrial robots. Okay, if you want only linear joint we can use linear motions, we can use linear joint. If you want orthogonal, okay, once again this is also another type of linear joint, and if you want some rotational motion then we can use rotational joint, twisting joint and revolving joint. So these are all the main types of joints used in industrial robots. So first we'll take linear joint. Okay, how the linear joint works and how it looks. You can observe in the diagram here. So this is okay. This is called the joint, okay, of the industrial robot. So here we have input link and the output link. By using this joint we can have linear motion in the robot. So the joint we can observe here. So the arrow mark is shown. So this arrow mark indicates that okay in the joint by using this linear joint we can have linear motion in this direction. The input link will give some motion to the output link so that output link also can move okay forward and backward. Next we have orthogonal joint. Okay, this is also another type of linear joint, but we can observe here the output link is here and input link is here. The joint motion takes place like this. It can move okay whatever the arrow mark shown in this fashion it will have the motion, but the output link is here, so input link moves here. Another joint that is called rotational joint. So in this rotational joint we can observe here the input link is this and output link is this, and this is the joint in the rotational joint. So this rotational joint will give rotational motion to the output link that we can observe here in this diagram. So this output link will have a rotational motion in the joint. So this is the twisting joint. In the diagram we can observe the joint, okay, how it is. The joint we can look, and here input link is this and output link is this. This output link can twist due to the, okay, twisting joint. So next we have revolving joint, okay. So this output link can revolve, okay. We can observe the joint here how it is constructed. So due to this, okay, so input link will create the rotational, sorry, revolving, okay, in the revolving type of motion in the output link, so that the output link will have revolving, okay, motion. This is called the revolving joint in the industrial robot. So next we have robot, okay, physical configuration. How we can construct the robot? What are the different physical configuration of the robots we have? So there are four different types of physical configurations of the robot. So first, the physical configuration of the robot is called Cartesian configuration. Second one is called cylindrical configuration. Third one is called polar configuration, and fourth one is called jointed arm configuration. So like this, we have four different types of robots configuration. We'll understand one by one. Okay, what is Cartesian configuration of the robot, what is cylindrical configuration of the robot, and what is polar configuration of the robot and jointed or configuration of the robot. So first, configuration of the robot, that is called Cartesian or rectangular or gantry type of configuration of the robot. So we can observe in the diagram, okay, only rectangular shaped, okay, links and joints we can observe here. So this is in the rectangular shape, and this is also having rectangular shape. We can see there is a small hole inside this. We have another rectangular block, and here we can observe this is z axis, and this is x axis, and this is y-axis. Okay, so this is y-axis, and this is z-axis, and this is x-axis. In these three axes, we can have only linear motions in the Cartesian or rectangular or gantry type of configuration of robot. We don't have any rotary motion, we don't have any twisting motion, okay, so, or revolving type of motion. Only the robot can have linear motion, okay. So this whole assembly can move up and down, okay, whatever the arrow mark shown we can observe, okay. According to this, the arrow mark, it can whole assembly along this and this, it can move up and it can move down. And okay, so we can see this thing, okay, so only this part, okay, so this part and this part can move in this direction in the x-axis, and this can have the motion in the y-axis. This is called Cartesian or rectangular or gantry type of configuration of the robot. We can have a robot that can have only linear motions by using this type of configuration. Next we have cylindrical configuration of the robot. We can see this is the base of the robot, and here we have a cylinder, we can see, and inside this and again outside we have another hollow cylinder, and this cylinder, solid cylinder, is inside the hollow cylinder, and we can observe this is the another part of the robot configuration. So in this, okay, robot can rotate 360-degree on its own axis. This, okay, shown in the arrow mark here, that is the rotary, okay, joint, and it can have rotary motion, and this thing can move in and out, okay. So this part, whatever the part you can see here, so this part can move in and out, okay, so in the another axis. And here we can observe this whole thing can move up and down, and it can slide in the cylinder, on the cylinder. So this is the cylindrical configuration of the robot. So I have discussed two configurations. Another three configurations of the robot we are going to discuss in the next video. Thank you.